So yet again, this is our 2013 Unit 2. Well, Unit 1, Paper 2. Right, so a continuation of our buffer and pH little series there with past paper questions. So this is the first question here under our kinetics and equilibrium section. All right. So number 2A, right, they've asked us to define the term a buffer solution. So what's a buffer solution? Go ahead, Shadi.
So, a buffer solution is a solution that has the ability to resist minimum changes in pH when small amounts of acid or alkali is added to the solution.
All right. Okay, you said minimum changes. Okay. So reducing the type of drastic change, right, to the pH when small amounts of acid or base are added. Lovely. And that's just the first part of a fairly simple video. Alright, so the next part, we're asked to explain using relevant equations how a buffer solution containing ammonia and ammonium chloride reacts in the following circumstances. Right, so what happens when this buffer solution is contaminated um, with a small quantity of base? What we would say, what would happen to the base when we add it? Remember, it's a solution of ammonia and ammonium chloride. Do you think we should write our equation first? Or like general, should we write what the buffer is first and then continue to explain so we don't make any mistakes? Yeah, because there are procedures. So if you see a question like this, more than likely my first reaction is to write out what that buffer would look like, right? So what we're having is ammonia NH3, right? We're reacting that with water. Well, are we reacting it with water though? We're having ammonia and ammonia. Well, it has to be a salt specifically, right? So let's say that it's reacting with hydrogen chloride. It's going to be an acidic solution, right? So let's use this acid instead, right? And then we're going to have the creation of something like this. So we're going to have our NH4 ammonium. Why that look like a Y? Right? Ammonium, right? And then we're going to end up with chloride ions, right? So that's the ammonium chloride that's going to be created there. Alright, so that should be fair enough, yes? So when we add a small amount of base, let's say that our base is represented by the hydroxide. Right, so let me just do that. If we add base, which substance or which component will be reacting with it? If we add a base, what will act to neutralize the base? What will act to neutralize the base? Is it, does anybody have an idea? The acid, lovely, right? So the acid specifically will act to neutralize the base, and our acid here would be um our ammonium, right? So what's gonna happen here is the ammonium ions themselves. Technically, what's happening here is that it's ammonium chloride existing as an ionic compound. So what's gonna happen here when the ionic compound is dissolved, it's going to be ammonium ions and chloride ions, right? So the ammonium would actually lead to the production here now, right? Of right, we're gonna have the production here of ammonia. Remember, it's ammonium chloride, we're looking at. So it's that look kind of weird. What I'm trying to represent here is the chlorine ion or the chloride ion. that is present. And we're gonna, okay, let's put the chloride ion out here, right? So there's a reason why I'm writing the chloride ion in this case, because it's not as straightforward with hydronium ions as we would think it would be, right? So I would think that this is how it is to be done. You must take note of the chloride ions, because what's gonna happen with the ammonia, when the ammonium itself reacts with the OH, right? We're gonna have the creation of ammonia and what else? A conjugate acid, right? Right, guys? So if we have that, if we're gonna react, right, what we're gonna end up with is ammonia, right, as a product, and that ammonia will produce hydronium ions. Well, water actually. Let me not say that, water, right? And then the chloride will actually exist like that. All right, so I actually was looking at it a bit weird. So it's actually fine. It's actually more than likely fine. What we're gonna basically have is just chloride ions somewhere off in solution. So the chloride ions still exist, but the main equation we're looking at it, eliminating all spectators, will generally just be this, right? So we're gonna have this reaction here, right? And you should be able to explain what happens here, right? Because if we're gonna have a small quantity of base being added, what we're going to be doing is decreasing this concentration,
Where are you breaking up?
breaking up. I'm not. It's probably the connection or something. Um, not sure I can do about that.
You're breaking up.
Okay, give me one moment. Let me just do that. I don't want to be breaking up while explaining. Is that a bit better? Can you guys hear me a little bit better now? Is everything a little bit better now?